So we're going to take a look at the mean value theorem for integrals today. But just as a quick review, what was that mean value theorem that we learned so many weeks ago? Well, if you recall, basically it was a way of saying that the average rate of change, in other words, the average slope between 2 points, A and B, was going to be the same as at least 1 point on the graph. At least one, in this case 2. The instantaneous rate of change would be the same as the average rate. In other words, whatever your average value is, your instantaneous value is going to be exactly the same at least once. So how does this apply to integrals? Well, here's the connection. Integrals are all about area, not slope. So imagine you find this line right here, and that's the average height of my function from A to B. Somewhere in there. The mean value theorem for integration, or for integrals, tells us that there's got to be at least 1 point where the function, at least 1 point, maybe more, where the function is going to be equal to the average value or the average height of this graph. And that point is right here. Now, here's what I want you to remember. If this is the average height, the area of this rectangle right in there where my hand is, the area of that rectangle should be the exact same as the area under the graph. The total area under that graph is the same as if I just found, instead of a changing height, I just took the average height or the average value. And the area under the rectangle on the graph should be exactly the same. So let's look at this again. The integral from A to B, the area under the function from A to B has to be equal to the area of the average height. And this is where I'm going to really mess up the picture here, but I'm going to try and draw the average height of that function. That means that, hey, I know this is a bit of an overestimate right here and right there, but it's a bit of an underestimate there. If the area of this little space fills in those, it's perfect. Whatever the average height is, and every function along some kind of closed interval is going to have an average height somewhere. And it's got to cross the function at least once. We know that the area of that average height is just going to be a big old rectangle. The width of the rectangle times the average height. Which is going to bring us to this equation right here. This is the one I'm looking for, the average value of a function. Why do you need to know the average value? I don't know. Maybe you're looking at how things are going for the company over the month. I know you have some good days and bad days, but what were my average sales throughout the month? What were my average profits? What were my average uses for different ingredients or things like that? I'm thinking of my cousin who works for King Arthur Flour, and she does forecasting. She has to predict, using mathematical equations, exactly how much they need to make of each ingredient or flour or sugar or specialty items for each month, because they need to know what they're going to sell. So the average values are really kind of important, but it's very simple. You just take the area of the whole shape and divide by the width. If you take the area of the whole shape divided by the width, that'll give you the average height. It's as simple as that. And here's an example that was actually in the AP exam just a couple of years ago. They gave you, basically they were telling you about a funnel, and one of the parts of the problem was saying, what's the average radius of this funnel? It's not straight sides, it's curved sides. And so they gave you an equation. The radius is definitely dependent on basically what the height is from the bottom. You can find the radius by knowing the height. Part A of this free response question was, what is the average radius? Well, to do this, you know that you're going to take the integral. Then you need to know the limits. If the height goes between 0 and 10, that's going to be my limits, a lower and upper limit of 0 and 10. Then finally, for the average height, you need to make sure that you divide by the width, divide by B minus A. And you can use your calculator on this part to find